I am Dr. Ashish Vikhar, and today we will proceed for very interesting lecture based on the subject power engineering and refrigeration. This is the subject as a part of syllabus according to MSBT, and the topic that we will cover today is topic number 2.1, and the name of the topic is IC engine testing parameters. Before proceeding to our lecture, I would like to appeal you all to subscribe my YouTube channel Knowledge Link by me, Dr. Ashish Vikhar. You can refer my website also www.drvikhar.com. So let us see which are the IC engine testing parameters. We all know how the internal combustion engine works. In this particular figure, you will see the different strokes which occurs inside 4-stroke IC engine. You will see the first figure nothing but related to the suction stroke. Second figure is for compression stroke. Third figure is for power stroke, and fourth is nothing but exhaust stroke. So these are the 4 strokes that we can have with a 4-stroke IC engine. In suction, piston moves downward towards inlet valve open, and in compression stroke, piston moves upwards, and during this both the valves closed. You will see that both the valves are closed. In case of power stroke, piston moves downward, again both the valve closed, and in exhaust, piston moves upward with the exhaust valve open. So this is a generalized working of 4-stroke IC engine, and related to that internal combustion engine, which are the testing parameters that we are going to learn today. First of all, we will learn what is torque, what is speed, power. Power means what is meant by indicated power, what is brake power, and what is frictional power. After that, we will define mechanical efficiency, thermal efficiency, volumetric efficiency. Then how to define brake mean effective pressure, specific power output, specific weight. BSFC means specific fuel consumption. And after that, we will see 2 important parameters, what is heat balance and air fuel ratio. So let us start what is torque in automobile. So torque is a twisting force. So it is one type of twisting force that speaks to the engine's rotational force. So it is nothing but a rotational force of an engine, and measures how much of that twisting force is available when an engine exerts itself. So this is nothing but, in short, the meaning of term torque. So it is nothing but a twisting force which is available when an engine exerts itself. Next is torque is present in everyday happenings, such as operating a door knob, opening a soda bottle, using a wrench, or pedaling a bicycle. These are some of the examples where we can have to measure the torque, or a torque is needed in all such examples. So it's a torque that gets the job done. Imagine we are tightening a bolt using a wrench. You will apply some amount of force to the end of the wrench, which is transferred to the bolt at the other end. This applies torque or twisting force to the bolt. So torque provides a simple measurement of the maximum twisting force that engine can generate when worked hard. This is why pickup trucks have high torque engines that generate more torque than a small car. So this is very important. Trucks have high torque engines than a small car. So let us see the example here. You will see in front of you two cars. Car A, this is the car A, which is having two important parameters. The car A is of 100 bhp power and 250 Newton meter torque, while car B is having 150 bhp power and 200 Newton meter torque. It will see that car B particularly, which is of 150 brake horsepower and 200 Newton meter torque, having better parameters than car A, only having 100 bhp. So comparing the bhp, car B is having 150 bhp and car A is having 100 bhp, means brake horsepower of car B is more than car A. What it means? It means that car B has a more bhp. If a car B has a more bhp than car A, then car B will move at a much faster rate, because car B is having more brake horsepower, that is 150. So car B will move at a much faster rate because of more brake horsepower. Now let us load both of these cars A and B with a 4 passengers and some luggage. Now torque plays an important role, because less torque car is B will be more stressed and its performance deteriorate, while car A generate more torque and carry load easily. So bhp affects the vehicle speed, while torque impacts load bearing capacity. So torque is impacting load bearing capacity, while brake horsepower affects the vehicle speed. So diesel engine produces more torque. This is nothing but everywhere inside every type of diesel type of engine. So how to measure this? A dynamometer or dyno in short is a device for measuring force, moment of force, which is called as a torque or a power. For example, the power produced by an engine, motor or other rotating prime mover can be calculated by simultaneously measuring torque and rotational speed RPM. So how to compare torque and power? Torque is measured in Newton meter while power is measured in bhp. So here torque is a rotating or twisting force produced by the engine, while you will see that twisting force, torque is nothing but a twisting force, and power is the rate at which an object does the work. Torque is nothing but engine's pulling force, which helps vehicle with the initial acceleration, while a vehicle with more power will have better acceleration and higher top speed. So torque, we can have the formula force multiplied by distance. So force is measured in Newton while distance is measured in meter. So force multiplied by distance, it will give us a torque. So torque generally is nothing but indicating the strength, while bhp is somewhat related to the speed. So bhp represents the speed. So brake horsepower or horsepower at the output shaft of the engine or turbine or motor. So what is power? The main purpose of running an engine is to obtain mechanical power. So it is defined as a rate of doing work. Power is having the formula force multiplied by linear velocity. So this is very important here. Power is nothing but force multiplied by linear velocity. Or power is also defined as torque multiplied by angular velocity. So these are the two formulas to calculate the power. Next, define how we can understand the meaning of vehicle speed. Speed is a distance defined as speed is defined as the total distance traveled by an object in a unit of time. So speed is equal to total distance traveled upon total time taken. So SI unit of speed is meter per second. Hence, to determine the speed of a vehicle, the distance traveled by the vehicle is measured, then dividing it by total time taken by the vehicle to cover that distance. So in this way we can define vehicle speed. Some of the examples you will see that stationary objects not moving or a parked car is having a speed 0 km per hour. After that you will see that average human walking speed is 1 meter per second or 3.6 km per hour. After that you will see that easy cycling speed on a bicycle is having a speed 20 km per hour. Typical car speed on residential roads or busy city roads is 50 km per hour. Vehicle on main road traveling reasonably fast is having a speed 80 to 90 km per hour. Fast car on motorway, typical speed of cheetah running or freight trains are 100 to 120 km per hour. High speed trains runs using the speed 200 to 300 km per hour. Racing cars 360 km per hour. So in this way we can have an idea regarding vehicle speed. Another example, airliner cruising speed is around 800 to 1000 km per hour. So how to measure the speed? A speedometer is the instrument that indicates the speed of the vehicle, usually combined with a device known as odometer that records the distance traveled. Let us define indicated power, brake power, frictional power. You will see that here there is a number 1 which is called as engine cylinder, which is connected to the clutch. After that there is a gearbox. After that there is a transmission shaft, and fifth number is rear wheel unit. So indicated power first that we can have here inside the engine. So let us see what it means. Any engine is specified by a preliminary term Cc, cubic capacity, which indicates the amount of fuel that can be burnt in the engine. This fuel burnt in the engine exerts a force on a piston which drives connecting rod, which further rotates crankshaft. The power output produced at the end of crankshaft is called indicated power. So this is the definition of indicated power. The power output produced at the end of the crankshaft is called as indicated power, or which indicates the power produced by combustion of fuel, actual combustion of fuel in the engine cylinder. So this type of power is produced inside the engine by actual combustion of a fuel. This power then get transmitted to the wheels through transmission unit like gearbox, couplings, shaft, steering mechanism. This power output at the wheel, the power output at the wheel is called as a brake power, which can be put in one term, net power, that can be used to drive the vehicle. So brake power is used to drive the vehicle. The power lost while transmission from combustion chamber to the wheel is called as a frictional powers. So in this way, these are the three important powers. One is called IP, means indicated power, brake power, BP, and frictional power. So frictional power we can define using the formula indicated power minus brake power, we can have a frictional power. Next is how to define thermal, mechanical, and volumetric efficiency of internal combustion engine. Thermal efficiency is the ratio of work done or power developed by the engine to the rate of chemical energy or heat supplied by burning of the fuel in the engine. So it is one of the ratio which is nothing but the ratio of work done or power developed by the engine to the rate of chemical energy or heat supplied. It can be based on indicated power or brake power, and accordingly it is given as indicated thermal efficiency. Here there is a connection with the indicated power. So indicated power upon MF multiplied by C. If you consider brake thermal efficiency means brake power, then the formula becomes eta. On the basis of brake thermal efficiency or brake power, we can have brake power upon MF into C, where we can have the two terms. MF means what? Rate of fuel consumed in kg per second. C is nothing but calorific value of the fuel in kilojoule per kg. IP is nothing but indicated power, and BP is nothing but brake power in kilowatts. In this way we can define thermal efficiency. Another important efficiency is volumetric efficiency, and after that we will see what is heat balance. So volumetric efficiency is defined as again a ratio of actual volume as reduced to NTP, means normal temperature and pressure of the charge or air drawn in during the suction stroke to the swept volume of the piston. So it is one of the ratio. While heat balance is defined as this gives the distribution of heat supplied in various ways and thus an indication of the working of the engine. It is nothing but the indication for general distribution of heat supplied in the engine. So let us see what is the formula for volumetric efficiency. It is nothing but the ratio of actual volume of the charge struck at a normal temperature and pressure divided by swept volume. So swept volume is there under consideration. So volumetric efficiency as an important performance parameter which directly affects the power output of an engine. More is the volumetric efficiency, more is the charge sucked per stroke and more power is produced. Mechanical efficiency is defined as ratio of brake power to the indicated power. So brake power to the indicated power is nothing but the mechanical efficiency, PP upon IP. Next term is specific power output and specific weight. Specific power output is defined as the ratio of the power produced by the engine to the displacement volume of the engine, or it is the power produced per unit displacement of the piston. So specific output is nothing but BP upon A multiplied by L. So here we can have the definition for specific power output. Specific power output depends on brake mean effective pressure and speed of the engine. By increasing the speed of the engine, we can more work output, but in that case the mechanical losses will be increased. In addition, increase in the speed results in increase in mechanical stresses of the various engine parts. Similarly, by increasing brake mean effective pressure, which requires better heat release and more load on the engine, power output can be increased. Specific weight, another important term, is defined as the weight of the engine in kg to produce unit shaft power. It is nothing but the weight of the engine in kg produce unit shaft power or brake power developed. This gives an idea of the engine weight. This parameter plays an important role in the applications such as engines used in automobiles and aircrafts. Next term is nothing but what is brake specific fuel consumption, BSFC. Is the ratio of mass flow rate of the fuel supplied to the engine to the brake power obtained at the crankshaft, and it indicates how efficiently the fuel is used to produce brake power. Mathematically, we can write here BSFC is nothing but fuel mass flow rate upon brake power or fuel consumption rate upon brake power, where brake power BP is nothing but 2 pi nt upon 60, where T is nothing but the torque at the crankshaft, N is the RPM of the shaft. Thus, BSFC indicates the amount of fuel used by the engine to generate a unit amount of brake power. Example, if BSFC of an engine is 200 gram per kilowatt hour, then it means that the engine uses 200 grams of specific fuel to generate 1 kilowatt hour of brake power, where brake power is power at the end of the crankshaft of the engine. The importance of BSFC is the BSFC says how efficiency the particular fuel gets converted into the brake power. The lower the value of BSFC indicates that engine require less amount of fuel for the generation of the unit amount of power. Second, it is helpful to compare different automobiles based on their ability to convert fuel into the brake power. And third is the BSFC can be converted into the brake thermal efficiency by using the following formula: 1 upon BSFC multiplied by CV multiplied by 100, where CV is the calorific value of the fuel. So BSFC says how efficiently the amount of fuel gets converted into brake power. Thus, on this basis, it is easy to compare the efficiencies of different engine irrespective of the other parameters like engine capacity, engine size, number of cylinders. The lowest value of the BSFC indicates that the engine is more efficient and if we increase the value of BSFC, consequently the efficiency of the engine decreases. In an SI system, the unit of mass flow rate is kg per second and the unit of power is watt. Therefore, the BSFC can be given by mass upon brake power. Mass is nothing but, or flow rate, kg per second upon watt. So kg per second upon joule per second, or kg per joule is the SI unit of BSFC. Let us see what is meant by brake mean effective pressure. BMEP is an average value of the pressure inside the cylinder, and if it is applied uniformly from top dead center to bottom dead center instead of the power stroke, then the engine will produce the same amount of brake power as an actual engine. So the brake mean effective pressure is used to compare different engines with varying engine capacity, and it is also used to determine how effectively the engine is functioning. The brake mean effective pressure is the ratio of work done by the engine during the power stroke to the engine displacement. So here we can have the formula work per power stroke upon Vd. The brake mean effective pressure shows the ability of an engine to generate the maximum brake power based on the engine displacement volume. The BMEP says the amount of brake power generated per unit volume of the engine displacement. Thus, it becomes criteria to compare the different engine irrespective of the size and the number of cylinder. For example, among the two engines of the same size, the engine with a higher brake mean effective pressure can generate higher brake power than the engine of the same size having the lower brake mean effective pressure. What is the significance of brake mean effective pressure? The brake mean effective pressure is the method to compare the different engines with different engine specification. The BMEP also relates the temperature of the gases in the engine cylinder. The brake mean effective pressure gives the average pressure inside the cylinder during the power stroke. The BMEP shows the compactness of the engine to produce a certain amount of brake power. The engine that have higher BMEP are more compact. It means that the engine can produce higher power with a smaller size of engine. So this is nothing but the significance of brake mean effective pressure. The BMEP depends on the factors like engine volumetric efficiency, the density of intake charge, compression ratio, etc. The brake mean effective pressure of the engine is also given by 2 pi n upon Vd, where T is nothing but torque at the crankshaft, small n is nothing but number of crankshaft revolutions during one power cycle, and Vd is nothing but engine displacement. For two-stroke engine, the value of small n is equal to 1. Therefore, the brake mean effective pressure is given by PBM is nothing but 2 pi T upon Vd. And for four-stroke engine, we can have n is equal to 2. Then the formula becomes 4 pi T upon Vd. So 4 pi T upon Vd is for four-stroke engine, and 2 pi T upon Vd is nothing but for two-stroke engines. Let us see what is meant by air-fuel ratio. This ratio shows the relative proportions of air and fuel in the combustion chamber. So air-fuel ratio is nothing but mass of air upon mass of fuel, and fuel-air ratio is nothing but mass of fuel upon mass of air. In this way, we can have the definition of air-fuel ratio. Next is exhaust smoke and emission. Smoke indicates that the combustion of the fuel is incomplete and naturally it limits the power output. Exhaust emissions are oxide of nitrogen (NOx), unburnt hydrocarbons, and are the nuisance to the public and environment in general. Exhaust emissions are nowadays considered as the engine performance parameter. So in this way, we have studied different engine testing parameters. Please subscribe my YouTube channel Knowledge Link before studying and start further studies. My YouTube channel name is Knowledge Link, in the bracket that is nothing but written my name, Dr. Ashish Vikhar. Thank you very much.